Over the decades, anti-gravity has been the stuff of science fiction. Though there have been many inventions purporting to be anti-gravity devices, from gyroscopic lifters to superconducting magnets, so far there has been nothing that is truly capable of nullifying, shielding, or modifying what we know as gravity. So could a form of anti-gravity even be possible given our current understanding? Just to be clear, what I'm referring to when I say anti-gravity is a way to either nullify or modify the effect of gravity that does not rely upon other forces like electromagnetism or some form of thrust, for example. Whether this would be some kind of local effect that creates a negative form of gravity or modifies gravity so its effect is either increased or decreased. Almost everything so far which has been claimed to be a form of anti-gravity is really just using other known forces, though there is a very interesting effect which, if verified, could be the closest we have come so far, and we will look at that later. A plane might be called an anti-gravity machine because it can lift you up and away from the surface of the Earth, but it's actually using the pressure differential of a wing travelling through the air at speed to create lift. A rocket does a similar thing, but by burning fuel which expands rapidly, creating thrust and pushing it along. And with enough thrust it can overcome the pull of Earth's gravity, but it's nothing more than a chemical reaction. In the 1980s and 90s, gyroscopic inertial thrusters were seen as potential sources of reactionless thrust. When seen in action, they appear to be able to generate lift and defy gravity. They use various methods of leverage against the support of a large gyroscope or flywheel. This appears to generate lift when the angle of the gyroscope is changed, but after years of theoretical and laboratory testing by NASA and others, no thrust or anti-gravity forces in free space were found to be produced. Other so-called anti-gravity lifters using the Bifield-Brown effect are in fact using the propulsive force of ion flow. By charging a very lightweight object or lifter, usually with a high positive voltage, the surrounding air is ionized. As the ions are attracted to the opposite negative electrode, usually on the ground, they interact with the neutral air molecules in between, creating an air flow with enough force to levitate the lifter. While some claim that the effect works in a vacuum and therefore must be some form of interaction between the electric field and the Earth's gravitational field, and implying that it could be used to create an anti-gravity effect, when NASA tested it in a vacuum equivalent to that found at low Earth orbit, the effect disappeared, proving that it was caused by the propulsive force of ions pushing on the air. Although gravity is one of the fundamental forces and thus anti-gravity would be theoretically impossible, it has been proposed that if another force could attract matter or repel it like a theoretical anti-gravity, then maybe a machine could be made to simulate that effect. In scientific papers published between 1991 and 93, American scientist Ning Li claimed that anti-gravity effects could be achieved if the ions in a Bose-Einstein condensate, that's a state of matter where all the atoms in it can act like one, could be trapped into a high-temperature superconducting disk with a time-varying magnetic field. A huge amount of energy could be stored in its lattice structure. As each ion would spin rapidly, it would create a tiny gravitational field. However, because all the ions from the Bose-Einstein condensate would be aligned together, the effect would be magnified by the billions of ions in the disk. The theory is that this would create a gravity-like field that could either increase or decrease the effect of gravity, which Ning Li called AC gravity, because it could either be attractive or repulsive in nature. She said that the experiments in the lab had created a beam-like effect above the disk which affected matter for some distance and backed up the theories. Even though it created a lot of interest at the time, in 1997 she published another paper saying that new measurements with a more sensitive gravimeter had shown its effect to be either very small or non-existent. In 2000, Ning Li left the University of Alabama and set up her own company, AC Gravity LLC, and in 2001 was awarded a grant worth just under $450,000 from the Department of Defense to investigate it further. Since then, she has all but disappeared and nothing more has been heard about her research, but the company AC Gravity LLC is apparently still in business. Experiments carried out by Yevgeny Podkletnov in the early 1990s using rotating superconducting disks in a magnetic field claimed to decrease the effect of gravity by about 2% on objects placed above the disk, and again it appeared to act like a beam above the disk for a considerable distance. However, these results had not been able to be verified by other scientists. He claimed that the other researchers had not used the same setup and that's why they couldn't reproduce the results. And when NASA was about to complete the experiments, they ran out of funding and the research was taken over by the Department of Defense, and he was shut out of any further research in the US because of his Russian citizenship. This and Ning Li's work is said to have prompted Boeing to investigate the effect of rotating superconductors with Project GRASP, Gravity Research for Advanced Space Propulsion, with potential uses including space launches, artificial gravity on spacecraft, aircraft propulsion and fuel-less electricity generation. Though others have pointed out that if the effect could be proven and directed into a beam, then it would be able to be weaponized, creating a steerable artificial gravity force to destabilize missiles, planes and satellites. Since the information has been released, Boeing has backtracked a bit and said that it was offered the proposal but chose not to fund it with company money, but refused to comment if it was a black project on the company books. These and other experiments are based on the idea of gravito-electromagnetism, which looks at analogies between Maxwell's equations for electromagnetism and Einstein's equation for relativistic gravitation. Basically, the premise is that just as a spinning electron creates a magnetic field, then a massive spinning object like the Earth would create a drag on space-time, a bit like when you spin a ball in a viscous fluid like oil. Although this drag was predicted nearly 100 years ago, Einstein called it frame dragging, it's taken the best part of a century to prove if it actually existed, with several independent satellite missions which did indeed measure a small but noticeable dragging effect. This is important because our current theories of gravity are that mass curves otherwise flat space-time, and this deforming of space-time is gravity. This is shown quite well with the weight in the rubber sheet experiment, which represents the sun which pulls the sheet down in the centre. A ball rolling in a straight line follows the curve of the surface, and this is like the Earth which is travelling in a straight line but is caught in the curve of space-time created by the sun's mass. And so long as the Earth's speed is constant, it orbits the sun. If the dragging effect is real, then it is affecting gravity, and a moving object near a massive rotating object would experience acceleration not predicted by Newtonian laws. It's been suggested that this is the effect is what might be behind the massive jets of gas which are ejected from quasars and galactic nuclei. Rotating supermassive black holes at the centres of galaxies would also create enormous frame-dragging effects. This is where the spinning superconducting disks in Ning Li's and Project GRASP experiments come in, to simulate this frame-dragging and the gravitational warping effect, but on a very much smaller scale. But the elephant in the room is that we still don't know what gravity really is. Yes, we have Newton and Einstein's laws which predict with amazing accuracy the effects of gravity, but these theories don't tell us how gravity works, or what the mechanism is that makes mass bend space-time. All we know is that gravity is a consequence of mass. the greater the mass, the greater the bending of space-time, and hence the greater the gravity. Although gravity works over huge distances on the grand scale of planets, stars and galaxies, we don't know how it really works on the very small things at distances on the atomic scale, because the effect then is so weak and difficult to measure. Conversely, we don't know how it works where gravity is incredibly strong, such as in a black hole. There are many theories as to how gravity actually works, but none have been proven. In quantum mechanics, there is a prediction that a force-carrying particle called a graviton might exist, even though we have found no proof of their existence so far. But as all the other three fundamental forces, the strong nuclear force, the weak nuclear force, and the electromagnetic force, have at least one force-carrying particle, it's believed there must be one for gravity too, if gravity is a true force. Gravity appears to have virtually no interaction with any of the other fundamental forces and works on any form of matter, even ones which we currently cannot detect, namely the still unknown dark matter. There is also no known way to shield against it, because it's bending space-time, which is the underlying fabric of the universe, and as such, it's not really a force. We only feel its effects when we are stopped from moving, when we are standing on the ground, for example, and being pulled by the mass of the Earth below. If we were free falling in space above the Earth, we wouldn't feel its effects at all. Then there are the observations of the physical universe that show that the rate of expansion from the Big Bang is speeding up instead of the expected slowing down under the effect of gravity. So either we have a major problem with our theories of gravity, or there is something else that is providing a yet unknown force which is overpowering gravity and pushing the universe apart in all directions, which we currently call dark energy. And like dark matter, we cannot detect directly, but can only see the effect it has, a bit like gravity itself. So given all of this, is true anti-gravity or some form of gravity modification a realistic proposition? We still don't know if anything has really come from the research by Ning Li and Project GRASP. It's been rather quiet on that front in recent years despite the internet rumours. A source at NASA said that the science appeared sound, but the difficulty was in scaling it up. Maybe at some point in the future, when we have a much better understanding of what gravity is and how it really works, will we find a way to manipulate it as we want. But unless a new breakthrough is announced, it still appears to be in the realm of science fiction. Although we might not have a complete theory of gravity for many years to come, it's not for the want of trying. There are dozens of competing theories from some of the brightest minds out there. But where do you start in a subject as complex as quantum gravity? Well, our sponsor for this video, Brilliant.org, can help you out. Brilliant is a problem-solving website that can help you develop those skills by breaking down complex problems like gravity down into small, easily understandable parts, then putting them back together to show the overall solution build up to an interesting conclusion. There are loads of totally interactive courses, explore gravitational physics and how gravity affects things like the tides on the Earth as well as the motion of the planets. Then discover quantum mechanics and the strange counterintuitive behaviour of the subatomic world. This hands-on active learning approach is great for curious people like you who want to understand the world. So if you want to support Curious Droid and get unlimited access to all of Brilliant's in-depth math and science courses, head on over to brilliant.org/CuriousDroid to get 20% off of their annual premium subscription.